Greetings, the Astro 30 here, and today when I came home from work I found this package in my mailbox. Now, it's not what I was expecting, but it is something else I can be getting on with in the interim. This is an FG085 mini DDS function generator, and it cost me all about $49.58 Australian off of eBay. Now, the reason I got this is because another YouTuber, Dr. Cassette, actually assembled one of these, and I was actually quite impressed with the results of, well, a cheap kit like this. Now, I've already cut the bag open because I was curious and had a look, and that's the bag of parts. And because I'm in Australia, I've got this European socket to Australian socket adapter, but I'm not going to be using that, and I'll tell you why. In this bag also is a wall wart power adapter. Now, the funny thing is, when Dr. Cassette was assembling his kit, he was about to power up and test a module with this power adapter, and it blew up. So I trust this about as far as I can throw it. In fact, that's about as far as I can throw it, tossing it over my shoulder. However, it's 15 volt, 1 amp supply, so I'm going to buy a linear regulator kit from JYETech, which uses an LM317T, which can deliver up to 1.5 amp anyway, and I'm going to need, well, at least a 20 volt transformer, but I'll deal with that later. Let's look at what we got in the bag here. I'm going to keep the plastic bag. I'm actually going to put it all back in the plastic bag. Now, here's the beautifully done printed circuit board. As you can see, all the SMD components are mounted, so I don't have to worry about that. Display module, I'll leave that in its bag until I'm ready to put it on. We've got our test leads for the output, just a BNC with some flyer leads on the end, alligator clips. We've got our front panel, as well as this acrylic backing sheet, which I'm not going to use. That's the actual panel. That's also made out of acrylic. I'll get on to how I'm going to house it in just a minute. Now, there is a set of instructions. There is an assembly guide. It tells you the parts and the quantity of it, but it's basic. It doesn't really tell you what to place and where. Just the tactile switches, and there's a one with a red thing, red push button on it, which goes for the power button, etc., and a rotary encoder, but it's not really telling you much about the order of construction or whatnot, but it's probably pretty easy to put together. So I'm not going to have that much difficulty. I'm not sure what that's for. So that's the bag of components. They're mostly switches. There's quite a fair few of them. It looks like at least 20 switches. So that's going to be fun to assemble. Anyhow, how am I going to mount this in a case? Well, this case that I've got, that I had lying around for another project, which is a HB5912, the actual front panel is taller than the actual case, so it's not going to fit. Well, the circuit board's a little bit smaller than the front panel. Let me just try and look at something here quickly. I'll open up this bag. There's a good millimetre of difference on the sides here. See, there's quite a bit of a gap there. So this case is going to be absolutely useless for it. That is, of course, unless I file down the board, but then I've got to cut the panels, or one of the panels anyway, off at the sides, and this has got slightly rounded corners on it just to make it fit in there and stay there. I'm not really going to bother going that far. So that case is no good. So this will be used for another project later, eventually. So instead, what I'm going to do is I'm going to use the case from my power supply design that I was going to build into this plastic case. And because I'm going to need a 20 volt transformer, I'm probably going to get another 24 volt transformer that I've got two of down there, just so I can fit it inside the case, because I know one will fit in there nicely. Get a regulator module kit and then set it for 15 volts to power this unit. And I'll also buy a Dremel to cut out a square hole in this so that the board can sit behind it, and then this is mounted on top, well, the right way up, mounted on top, and yeah, go from there. It'd be a rather big case for it, but yeah, it'll do the job. It's better than using that crappy European wall wart, which I don't trust. So yeah, I'm not going to assemble this kit today, but I just thought I would open the bag and have a look at what I'm dealing with here. It's mostly looks like switches and a few electrolytics to mount. Anyway, I'll see you guys soon. By the time I actually see you again, it'll be about 4 or 5 days later. So anyway, I love bubble wrap. Can't go without coffee. Right, it's like 3 days later now. It's the 11th of January currently. I filmed that first part of the video on the 8th, and now I'm going to put together the FG085 function generator, which is made by JYETech, just like that DSO. And yeah, I'm going to do it in time lapse. There's not much really to say about this particular kit of assembly instructions. I'm going to leave the display module to the last part. There is a BNC connector socket in here which has to pass through the plastic front panel into the circuit board before it's soldered, so you put that on definitely last. And I don't think there's anything really special about these switches. I will check into it. The only difference is one's got a red thing on it and the others will have grey on it, but I'm pretty sure it's the same switch. Yeah, so let's get to building. I'll mount my circuit board in my handy dandy little tool here, and well, I'll put in time lapse me constructing the board. It's very straightforward. It's just a bunch of electrolytics and a couple of header pins and switches and a rotary encoder. There's really nothing to it. So let's get started. First, I might plug the camera into the power point because I've plugged it into the extension lead, but it's not actually plugged into the power point. We'll just say before I get started, you'll notice that there is on the silk screen here overlay outlines for components. So all the switches go on this side, so does the display. The output socket, which is here, goes through the board from the front. But you'll also notice that it's got silk screen outlines on the back as well. So there are some components which do mount on the rear. So there's one header pin here, which is a 4-pin dual in line, that mounts here, and you got a power socket, or well, you got the power socket there, or a jumper connector that goes on this side. So obviously, because when the front panel's on, you won't get access to it. So just keep in mind that you've got like header connectors and everything else on the rear of the board as well. So we start with the mini USB socket, which I probably won't be using because it'll be inside a case, don't forget. Then you move around to the capacitors, then the power adapter, and finally the header pins on the back side of the board. So that's the order I'm going to do that in. So this is how our board should look so far. Got mini USB connector here, two large 100 microfarad 25 volt caps, and three 100 microfarad 16 volt caps, plus two headers up here. Not sure what they're exactly for, but there's also supposed to be a header here, but there's nothing actually soldered here, so we don't put anything there. Now, with this power socket that it comes with, I'm not going to be using that because I'm going to be running an external power supply, which we'll get to a little bit later. So there's a facility here to actually mount one of these type of header terminals. So I've got that, which is a right angled one, which actually in this application would be perfectly fine. So I can actually pop him on the board there and straighten it up and solder it. And I've also got the accompanying plug, socket, whatever you want to call it, to put two leads in to get power to it. So that's the next thing. That's it. I'm putting my phone in flight mode. F off. Don't want to talk to you anymore. Right, so this might be a little bit more difficult and challenging to solder, so I'll just tack one end in so I don't have to hold it sometime today. No, sometime today. There we go. Now, make sure that that's straight as it's going to be, I suppose. So I'll solder the other end. So there's my power connector installed. So that's pretty much the construction of the underside of the board done. I can now move on to the next part, which is the top side. Okay, so following the instructions for part B, part 6 is you've got to install the header pin for the display, but I'm not going to mount the display yet, but I'll mount the header pin. 7 is mount the power switch with the red button on it. Number 8 is mount all the other switches with the grey button on it. And finally number 9 is the rotary encoder. So that's what I'm going to be getting on with now. Okay, and there's the 50 million switches installed. Well, actually 21. There's 20 over here, so I was good with my guess. There's 21. There's 20 over here, and there's one over here for the power. Now, the only difference between that switch and the rest of them is this one is a push in, push out locking switch, and these are momentary. So you push them in and they just spring straight back out. That's the only difference between the switches. Yeah, so I'm going to pop on the buttons. Okay, done. And the next thing to put on is this rotary encoder, and it only goes one way around because there's 2 pins on one side and 3 on the other, so you just match it up, pop it in and solder it. With this magnifying glass, it probably was not a very good idea to put it on the floor in front of a window because, well, it's kind of burnt the carpet, which is not good. Yeah. So, yeah, that was not a good place to put it. So just keep that in mind, not to put a magnifying glass pointing at a floor near a window. I know I'm surprised it didn't actually set the place on fire. We all make mistakes in life, children. Anyway, this is the second to last part of the assembly, which is installing the rotary encoder. Then I'll put the LCD display module in, and then we can work on front panel and getting power to it. So first I'm starting with the 2 large body tags of the rotary encoder because they'll take the most heat. I had a little bit of a break. I had to deal with my washing, and then the phone rang, so I went and dealt with that. Had a cigarette, which is, whilst I was having a cigarette, noticed the burn mark on the floor. Anyway, that's the rotary encoder installed, so that's nice. It's also one of those push ones as well. So I can put on the knob. I think I can put the knob on. Maybe I should just verify that with the front panel first before I put the knob on. I know I can put the switch knobs on. And this is the front panel, and no, I can't put the knob on because it goes on from the outside, and there is an issue with these switches lining up. So that's going to be fun to address. There we go. Yeah, so you put the knob on last when the front panel's on. So we won't put the knob on. Okay, so now I can deal with the display module, LCD. It's not a TFT, it's just a normal LCD. Okay, nice little bubble wrap bag here. So, it's blue in colour, so it might be a TFT. Now, we mount that to our header that we soldered on previously. I would assume flush with the board, and we've got 2 holes in the board here to put screws through to well, keep it central, but they haven't given me any spaces. There's nothing in the parts bin for that, and last thing we'll put on is this BNC when the front panel's on, so that's the last to go on. But there is no hardware for the module, so I'm just going to pop him on and not worry about it too much. Could always put some screws in it if I want to, but I don't really see the need. And so that's what it's going to look like assembled, minus the input socket. But that's what we're going for here at the moment. The next thing to do is to work on the front panel. But first I'm going to need to get a power supply, 15 volt, at 1 amps to power this module. I've been to JCar, again as usual. I should probably start living there because I'm in there all the time. And bought this adjustable 1.3 volt to 22 volt regulated power supply kit. It's a silicon chip May 2007 project, KC5446. Fairly basic to put together with an LM317T, and it doesn't come with a heatsink, but that's the next order of business, is to put this kit together. And well, there's the circuit board for it. It's tiny, isn't it? So there's the circuit diagram for anyone interested. We've got a bunch of protection diodes here, half-wave bridge rectifier, small capacitor, output capacitor, and the adjustment here. So it's pretty simple. And being half-wave rectified, it should work fine for the purpose I'm using it for. It won't be very clean, but well, we'll deal with that later. Now, before I get too excited, I did actually find this heatsink on a switch mode power supply, which I had sitting under the desk. That should be more than adequate enough to dissipate some of the heat out of this LM317T, which also the leads are quite bent on for some strange reason. So anyway, I've got to clean off all the old heat transfer compound goop and apply a liberal amount of new stuff, and that's just going to sit behind the board here. It's going to sit up at an angle because it's got this solderable locator pin, which I might just remove. If I do that, no more problem. However, I did just find this bigger one. Well, that's nice. I might actually use that one instead. I'm not sure what I pulled that off of, or why. Anyway, that might be a bit more of a sufficient heatsink to use rather than the one I was going to. Right, well, I've lost my little tube of heat transfer compound. I don't know what I used it for, but I can't find it now. So I'm going to use one of these spare TO3P isolators, as these are greaseless micro washers, or greaseless washers. I'll just slightly trim down the edges so it fits in the heatsink a little bit better. Not too much, just enough so it fits in there nicely. Get our device after dropping it. It doesn't need isolation because it's not coming into contact with anything that's earth related anyway. And I'll just put the screw back in the heatsink that came out of it. There's another one on the desk I've got to throw in. That's probably a pretty long screw, probably a bit too long for the job, but And they'll transfer the heat nicely. And we'll call this kit built. This only took me about 30 minutes. Now that center lead you're probably going to have to heat up with the heatsink mount on it, because the center pin is connected to the this tab here on the IC, and of course it's connected to a heatsink. So that's that little regulator board built. So now I can move on to the next part, which is dealing with the front panel. All I'm going to do is I'm going to cheat. I'm going to, when I can find a pencil, which did fall on the floor the other day, didn't it? And I never picked it up. Well, a pen will do then. Before I actually wet and take this paper off the plastic, I'm going to use it to help me assist in marking what I need to do, including the holes for the screws. So that's where the front panel is going to go. So I've got roughly 5mm of material between the screw hole and the edge of the switches. So I'm just going to guess this. I'm not going to be terribly accurate with it because, well, yeah, it's not going to be seen anyway. So if I drill a hole there, a hole there, a hole there, and a hole there, I can cut out the square in the middle. But how am I going to do that? Well, I bought one of these JYETech mini grinder with a flexible shaft on it, and it's a 202 piece, and it's a catalogue number TD2459, sorry, and it's basically similar to a Dremel. It's a clone. It doesn't come with its own carry case or anything, so that's annoying. Look at that. This is the flexible shaft. It's like a snake you use to get down drains and stuff. That's kind of cool. Or a bit like a speedo cable. Cable on the end there turns, which will turn this outer portion as well. I need the accessory shaft, which has a screw in the end of it, which goes into this chuck somehow. Now this probably would have helped me earlier when I was cutting that metal case, because this is pretty much the same material you buy for 110mm to 10-inch grinders. It's the same sort of material, so it will cut through most small gauge metal quite fine. So let's do him up. And then it will be just like cut it along the line, all directions, and go from there. But first I need to drill some holes. So that is going to be my first order of business, is to drill the holes. Yeah, those holes line up perfectly, so throw stuff on the floor. All I need to do is cut it out. It's a bit messy. Well, that was a heck of a lot easier. So I should just be able to snap out what's left over, and now I have a square hole. Check that everything's going to fit through here, which it doesn't quite, so I'm going to have to do a bit of manipulation to the top and bottom edge just to make it slightly taller, but lengthwise that should be fine. Okay, so the front panel is sized up and I've cleaned off the old label, and yeah, I went a little bit far with the Dremel close to these mounting holes, but yeah, that'll do. I was going to mount a mains power switch, a separate one to it, but I'm not going to worry about that now. I don't think it's really important. So next I'm going to mount my standoffs. Yeah, you need to, with this BNC socket, you need to solder on some pins to the board so you can actually solder it to it. I mean, I wish they told me that to start with. It would have been a lot handier than the way I was trying to do it. Now, I'm going to have issues with this BNC socket, so I'm going to cut out a portion of the plastic so that I can clear the BNC socket a little bit better. Well, the earth tag anyway. Okay, I think I've got it. I had to cut out a significant chunk out the edge here, but that doesn't really matter. It's not going to be seen. The panel covers it up. But now that my screw holes line up, I can think about, well, first I have to deal with that issue of the connections to the BNC socket. So a solution to that is this 0.8 of a millimeter link wire stuff, which I've had knocking about in place for a fairly few years. And I'm just going to put that through the board here in both relative places that it needs to go. So just keep that in mind, folks, that you're going to need some form of link wire to hook up the BNC socket later. So I'm going to leave myself plenty of wire. Do the same for the centre lead. And once it's in there, it's going to be fun to solder them, I can tell you. Yeah, don't know where that went. Leave myself plenty on there. Okay, so that's solved that issue. So, there's crap everywhere. So now I can probably marry up my front panel. Well, I'm going to put this earth tag through my socket first, so I've got that in there, because otherwise it's going to be a real prick to get in later. So I need... See, the problem I'm going to have is it's not going to be able to push the buttons properly, because there's too much distance there now. So what I might do is I'll change these 15mm spaces to 10mm spaces, because I've got some of them lying about. So 4 of them. Yeah. So I've just got to take this off. So I'm going to just do this off camera. So that does actually give me the clearance I need, because this panel is about 2mm thick. Yeah, and this front one's probably about 1.5 mm, so that adds an extra 4 odd millimeters to the distance away. So by changing the 15mm spacers to 10mm spacers, I cut that extra 4mm off. It's getting hot in here, so take off all your clothes. Okay, so I'll connect the negative lead of my multimeter to the negative lead of the output, and there's the connector there. So I'll find out which one's ground. So this top pin, this bottom pin here is the negative rail, so that would be the positive connection. So I'm just going to mark that with something so that I know where the negative side is, because it's not actually marked too clearly on the board that I could see anyway when I was assembling it, so we sort of have to make things up as we go along. Well, not make things up, but you know, do some tests before we get too carried away. Now, the fun bit. I need to take this case, I need to also drill a hole in the back panel for a power cord to go in. So I'll just put this in here. So there's plenty of space in there for it, and I reckon that looks sexy as hell. A bit like me. Egotistical much? Now, I never did like these ABS plastics because they can be a pain in the ass to get the case together. Right. That appears to have warped. Interesting. That's because the front panel's not in properly. That's why it looks warped. There we go. It's all together now. So that's what it will look like when it's together. I reckon that looks sexy as hell. So whilst I'm at it, I'm going to put my button on for the rotary encoder. So that's all on there now. I don't need to do anything else but wire it up now. And for that I'm going to need something else that I bought from frickin' hell. No, I didn't buy it from frickin' hell, I bought it from JYETech. Got a packet of strain reliefs that you put your cable clamp, you put the power cable through. So I'm just going to wire up the mains cable directly, and I've got a transformer here. This one is a multi-tapped 12 to 18 volt, 18 VA 1 amp, and it's an MM2011, and so that will mount wherever I can mount it. Now the standoffs are not helping me much, so I'm probably going to have to drill a hole, a couple of holes in the case here just to mount the transformer. So I'll mount him somewhere in the middle, and I'll put some rubber feet on. I'll get some later. I'll put some rubber feet on it to sort of like I don't even know where I was going with that. So it'll stop sliding around on the desk and scratching the desk. I think there's a good spot, even though the power's going to come in over this side. Yeah, there's a good spot. So I need something to mark it with. So do that. So that's the transformer sorted. This PCB will just mount here somewhere. I reckon that's going to be nice where it is. So I'll just remove this front panel out of the way. So I'm just using the leftover screws and reusing the standoffs I didn't use from the module just to act as a spacer. Waste not, want not, as they say. Now what I need to do is play with myself, is put this transformer in there, and I need the 4mm bolts and nuts for that. I'm really hoping that it all works as soon as I turn it on. But the first thing I do before I connect up the module, obviously, is adjust the voltage of that regulator so that it's at 15 volt, because I don't want to connect up 22 to it and kill it. As for a power cable, thought I had a 2-pin cable. I've got a 3-pin one. I was pretty sure I had a cut-off 2-pin one. It's only about 1 metre long. It came off of a coffee maker, I think. But yeah, it'll do the job. I'm not going to use the earth lead, so just going to strip back the outer insulation. Only pressing into the insulation. I'm not slicing through it like a knife. I'm just pushing on it. There we go. They're stripped. So I've got my power wires. That's going to go in the clamp like that, and the clamp's going to close down over it and keep it nice and hard in the case. But of course it's only going to be about 1 metre long, but well, for a test instrument you don't really need long cables on it. Okay, I've got a 3mm hole drilled here for the cable clamp and a 3mm hole here to mount the terminal block, and I just drilled them anywhere, I didn't measure it. Now I'm going to use this stepper bit, which goes up to 12mm, to drill out to 10. I'm not breaking out the drill press today, I'm just doing it this way. It's only plastic, so it won't take long. And as quick as that was, there we go. We've got our 10mm hole. Now I'm just going to verify that that's big enough for the clamp, wherever it's soldered off to. I don't know where it's soldered off to, but it's soldered off. So I'm going to have to grab probably another one, because I just lost the one that I had. Once it's on the cable. It's on the cable. Right. So is this going to fit? No, so I'm going to make it 12mm. There we go, she's in. That actually snapped in nice and tight, so that cable's not going anywhere. Now all I've got to do is mount the terminal block, so I need to cut a piece off this. Well, I can cut this earth wire off because I don't need it, so that's going. And I need to strip both the active and neutral wires. I'm just going to tin those wires. Like so. So that's that in. Yeah, I've got a power cord now. I'll plug it in the wall and see if I can electrocute myself. No, of course not. Now, bring this back up here. Now, these are already pre-tinned, so I don't have to do anything with them. So I just put my back panel back into the case. Properly put it back in the case like that, and then I'm not going to really shorten these wires, but I am going to screw them into the terminal block. Right, well I'm going to have to change this terminal block, that part, because that screw's not doing it, and then I'm pulling on the wires there to make sure they're not going to come back out. So that's in there. I'll unscrew the old terminal block shortly, but for now that's good enough to test. So we've got about 18.9, 19 volt there, so that's perfectly fine. This regulator can do up to 22 volts anyway. So I'm happy with that the transformer's working, which it should be, there's no reason why it wouldn't. So now I've got to find some wires to, well, solder them from the primary to the ground. So I'm going to look for some hookup wire now and go from that point. Oh, I can't see it, got all fuzzy. These are just reading glasses, but they do actually help. Glad I've got these reading glasses. They actually do magnify by about that didn't work too well. By about 10%, so I've got a little bit more magnification, so I can actually see what I'm doing, which is wonderful. Okay, that's solid. Right, I want to first measure and adjust the output voltage. So this is going to be fun doing it this way. I've got one there and one there. Now this is going to go to the negative probe of the meter. This one's going to the positive probe of the meter. About 14.7 volts, so it is pretty close. So if I grab a screwdriver, I want it roughly 15 volt. You'll take 2% error. Well, that's pretty dead close. I'm going to leave it at 14.98. That's close enough for me. So the power supply circuit is working. So now all I need to do is hook up power to this module. So that's plugged in now. Put the module back in the little front panel there. Plug him back in, make sure it's turned off, which it is. Plug him back in and turn it on. Oh dear. We have no power. Well, okay, that was interesting. I just removed the board and it now powers up. But it seems to power up with it the switch coming out instead of going in. It's off when it's in, on when it's out. That's really weird. So I can't seem to make it do anything. Might be that the switches are backwards. That could be the whole issue. I see, something's shorting it out too when it comes back into contact with the panel. Something is shorting it out. And I think I can see, so that end's being shorting it somehow. Okay, well that's not doing much at the moment. Put that back in its home. So I'll figure out what's shorting in a second. There's a little mark on the switch. That mark has got to face the power connector. I've probably put all those 20 switches in round the wrong way. So I've got to remove each one and turn it around, because if they're in backwards, it says it will no function. In other words, it won't work. So, right, time to pull it apart, get a bit more pissed off, and yeah, I'll come back when I've done that. Yes, I even had the power switch the wrong way around. If you look in this side of the switch, there's two little dimples. Took a lot to get it off the board, I can tell you. And on this side there's only one. The one with the two dimples in it should be orientated so it's actually facing this DC socket. So when I flip the board over like this, the switch with the two little dimples in it should be facing that way in the board, not the way I had it. So there's only 7 of these switches round the wrong way, thank God. I don't have to do all 20 of them. Getting this one off was hard enough. So I'll swap this around, test it again, make sure that the power button is off when it's coming out and on when it's in, and then I'll change the other 7 switches around. Okay, well, the one thing that happened that I didn't want to happen is when I was removing the next switch, it busted, and yeah, it fell apart because I had to put a lot of heat in to try and get it off the board, because it's double-sided board. It's almost, with plated through holes, it's almost next to impossible to unsolder something once it's soldered in. So where does that leave me? Well, it means I'm going to have to order another one of these. This is now garbage. I'll keep it for spare parts, but I'm not even going to attempt to try and take off the other 6 switches that are in there incorrectly. So what I'll do is I'll leave the video complete as it is now, edit it down, and even though I made a mistake, we all make mistakes in life, children, so I'm going to have to order a new one of these, assemble it. There won't be a video on that, but what I will do is do then an update video of putting it in the actual casing with the new board, and go from there. I can take my little power adapter socket back off this board and reuse it. So that's going to be it for this video. Anyway, that's a shame because I wanted to get it finished today, but not going to happen. So I'm the Astro 30. If you like this video, please remember to rate, comment and subscribe, and you can always follow me on Facebook and Twitter. The links are in the description. And just a final note, it's always a good idea to read the instructions thoroughly. So I knew there was something funky about these switches that you had to do. Now we found out what it was. So I can't use this board anyway. This is the Astro 30 saying, see you later, I'll order a new one.